पहले यहाँ पे देख लेते हैं, इसका माइंड मैप तैयार किया हूँ। तो 6.1 जो टॉपिक है इसमें क्लासिफिकेशन पढ़ेंगे। तो इसमें 2 टॉपिक आएगा, ऑन द बेसिस ऑफ हेलोजन एंड एटम्स और कंपाउंड्स कंटेनिंग sp3, इसको sp3 कार्बन और एक्स इक्वल फ्लोरीन क्लोरीन ये सब है, तो कैसे नेमिंग करेंगे इसको सब टॉपिक में पढ़ेंगे। 6.2 में नोमेनक्लेचर करेंगे इसका, आईयूपीएसी नोमेनक्लेचर, और 6.3 में नेचर देखेंगे, कार्बन और हेलोजन के बीच का जो बॉन्ड है, इलेक्ट्रोनेगेटिविटीज कैसे डिपेंड कर रहा है, पोलराइजेशन वगैरह जो भी है। 6.4 में पढ़ेंगे मेथड ऑफ प्रिपरेशन ऑफ हेलो एल्कीन्स को कैसे प्रिपेयर करें, जैसे कि एल्कोहल से कैसे बनाएं, और मतलब एल्केन वगैरह से कैसे बनाएं, ये सब करेंगे। 6.5 में प्रिपरेशन ऑफ हेलोएरिन्स करेंगे। 6.6 में फिजिकल प्रॉपर्टीज इसका करेंगे। 6.7 में इसमें केमिकल रिएक्शंस इसका, हेलो एल्केन्स का, उसके बाद हेलोएरिन्स का कैसे केमिकल रिएक्शन हो रहा है वो करेंगे। सबसे बड़ा टॉपिक यही है, SN1 SN2 सब इसी में पढ़ेंगे, तो सिर्फ NCERT रीडिंग करेंगे। उसका 6.8 लास्ट टॉपिक है पॉली हेलोजन कंपाउंड्स, जो इसमें जितने भी पॉली हेलोजन कंपाउंड्स अपने आ रहे हैं वो करेंगे। ठीक है भाई, तो लेट्स स्टार्ट। यूनिट 6 हेलो एल्केन्स एंड हेलोएरिन्स। Halogenated compound persist in environment due to their resistance to breakdown by soil bacteria. The replacement of hydrogen atom in a aliphatic or aromatic hydrocarbon by halogen atoms result in the formation of alkyl halide or haloalkanes and aryl halide haloarenes respectively. Haloalkanes contain halogen atom attached to sp3 hybridized carbon atom of an alkyl group, whereas haloarenes contain halogen atom attached to sp2 hybridized carbon atom of an aryl group. Many halogen containing organic compounds occur in nature and some of these clinically useful. These classes of compound find wide application in industry as well as in day-to-day life. They are used as solvent for relatively non-polar compounds and as starting material for the synthesis of a wide range of organic compounds. Chlorine containing antibiotic chloramphenicol, produced by microorganisms and very effective for the treatment of typhoid fever. Our body produces iodine containing hormones thyroxine, the deficiency of which causes disease called goiter. Synthetic halogen compounds, which namely chloroquine is used for treatment of malaria. Halothane is used as an anesthetic during surgery. Certain fully fluorinated compounds are being considered as potential blood substitute in surgery. In this unit, you will study important method for preparation of physical and chemical properties and uses of organohalogen compounds. 6.1 Classification. Haloalkanes and haloarenes may be classified as follows. 6.1.1 On the basis of number of halogen atoms. These may be classified as mono, di or polyhalogen, di, tetra, etc. compound depending on whether they contain 1, 2 or more halogen atom in their structure. For example, this is only one halogen, therefore monohaloalkane. This is dihaloalkane, and this is trihaloalkane, and this is monohaloarene, this is dihaloarene, and this is trihaloarene. Monohalo compounds may be further classified according to their hybridization of carbon atom to which halogen is bonded as discussed below. 6.1.2 Compounds containing sp3 carbon and halogen. X is equal to fluorine, chlorine, bromine and iodine. A. Alkyl halides or haloalkanes, Rx. In alkyl halide, the halogen atom is bonded to alkyl group R. They form a homologous series represented by CnH2n plus 1 into X. They are further classified as primary, secondary, tertiary to the nature of carbon to which halogen is attached. If halogen is attached to a primary carbon atom in alkyl halide, the alkyl halide called primary alkyl halide or 1-degree halide. Similarly, if halogen is attached to secondary or tertiary carbon atom, the alkyl halide is called secondary alkyl halide 2-degree or tertiary alkyl halide respectively. This is 1-degree primary alkyl halide. This alkyl group connected to a carbon that is connected by only one alkyl group, and it is 2-degree alkyl group halide. This carbon attached to 2 alkyl group, and this is the tertiary alkyl halide. B. allylic halides. These are compound in which halogen atom is bonded to an sp3 hybridized carbon atom adjacent to carbon double bond atoms. That is two allylic carbon. This is allylic carbon and this is allylic halide, because this halogen attached to that carbon, this carbon attached to sp2 hybridized carbon, and this is allylic carbon. This is also attached to 2 degree carbon, 2 degree sp2 hybridized carbon. Benzyl halide. These are compound in which halogen atom is bonded to sp3 hybridized carbon atom attached to an aromatic ring. This halogen attached to this carbon and this is attached to aromatic ring. This is 2 degree, this is 3 degree alkyl halide. Also benzylic halide. 6.1.3 compound containing sp2 carbon X bond vinylic halide. These are compound in which halogen atom is bonded to a sp2 hybridized carbon atom of a carbon-carbon double bond. This directly joined by sp2 hybridized carbon, and here not this is this halogen connected to this carbon. This is sp3 hybridized, but this carbon is sp2 hybridized. B. Aryl halides. These are compound in which halogen atom is directly bonded to sp2 hybridized carbon atom of an aromatic ring. So this is directly connected to sp2 hybridized carbon that is present in aromatic ring. Here is also it is connected to sp2 hybridized carbon. 6.2 nomenclature. Having learned the classification of halogenated compound, let us now learn how these are named. The common name of alkyl halide are derived by naming alkyl group followed by the name of halides. In the IUPAC system of nomenclature, alkyl halide are named as halo substituted hydrocarbon for monohalogen substituted derivative of benzene. Common and IUPAC name are the same. For dihalogen derivative, the prefix ortho, meta or para and used in common system, but IUPAC name system, as you have learned in class 11th, the numerals 1, 2, 1, 3, 1, 4 are used. Common name, this is N-propyl bromide, and IUPAC name is 1, 2, 3, 1-bromopropane. And in this common name of this compound is isopropyl chloride, but IUPAC name is 2-chloropropane. This is isobutyl chloride common name, but 1, 2, 3, 1-chloro, 2-methyl propane, IUPAC name. Common name bromobenzene, IUPAC name bromobenzene. This common name meta ortho, meta para. So meta dibromobenzene or 1, 2, 3, 1,3 dibromobenzene, IUPAC name. And this common name is symmetrical tribromobenzene and IUPAC 1,3,5 tribromobenzene. IUPAC name 1, 2, 3, 1, 2, 3. So 1-chloro, 2,2 dimethyl propane and 1, 2, 3, 2-bromopropane. The dihaloalkanes having the same type of halogen atom are named as dialkylidine or alkyl dihalides. The dihalo compounds having both the halogen atoms are further classified as geminal halide or gem dihalides. When both halogen atoms are present on the same atom of the chain and vicinal halide or vis dihalide, when halogen atoms are present on adjacent carbon atom. In common name system, gem dihalides are named as alkylidine halides and vis dihalide are named as alkyline dihalide. IUPAC name system, they are named as dihaloalkanes. CH3CH Cl2 common name dialkylidine chloride or gem dihalide. यहाँ पे देखें तो 2 क्लोरीन सेम कार्बन से जुड़ा है, तो इसको एल्किलिडीन क्लोराइड बोलेंगे या जेम डाइहैलाइड, बोलता है यूपीएससी नेम 1,1 डाइक्लोरोइथेन। हियर यहाँ पे देखो दोनों डिफरेंट कार्बन पे एल्किल ग्रुप जुड़े हैं, तो इसको एथिलीन डाइक्लोराइड या विच डाइहैलाइड बोलेंगे, आईपीएससी नेम 1,2 डाइक्लोरोइथेन। कॉमन नेम आईपीएससी नेम इसका 1 2 3 4, तो 2 क्लोरोब्यूटेन 1, इसको कॉमन नेम देख लेना यार, क्योंकि स्ट्रक्चर बनाने में टाइम लगेगा, इसीलिए जो इम्पोर्टेंट वो देख लेते हैं। जैसे देखो विनाइल क्लोराइड 1 2 क्लोरोइथीन, ठीक। विनाइल क्यों बोल रहा है, बिकॉज ये देखो sp2 है, हाइब्रिडाइज कार्बन डायरेक्टली ऐड हुआ है। एलाइल ब्रोमाइड 3 ब्रोमोप्रोपीन बोलेंगे 1 2 3, तो यहाँ पे ये जो कार्बन से जुड़ा है ये क्या है, sp3 हाइब्रिडाइज। क्या हो रहा है भाई, दिस इज sp3 और 8 H है sp2 कार्बन से, और यहाँ पे 1 2 1 क्लोरो 2 मिथाइल बेंजीन, और ये गया 1 पे क्लोरो है और फेनाइल मीथेन हो जाएगा, ये देख लेना। क्लोरोफॉर्म CaCl3 ट्राई क्लोरोमीथेन, इसका डिटेल पढ़ेंगे अभी। CCl पर कार्बन टेट्राक्लोराइड टेट्राक्लोरोमीथेन आईपीएससी ने। चलो ये कुछ इंपॉर्टेंट एग्जाम्पल्स हैं उसके कर लेना। 6.3 नेचर ऑफ कार्बन एंड हेलोजन बॉन्ड, तो बॉन्ड इस नेचर कैसा होता है इसमें। हाइड्रोजन एटम्स आर मोर इलेक्ट्रोनेगेटिव देन कार्बन, देयरफॉर कार्बन हेलोजन बॉन्ड ऑफ alkyl halide is polarized. The carbon atom bears the partial positive charge, where the halogen atom bears partial negative charge. So carbon and halogen, due to electronegativity, halogen possessed negative delta negative charge. As you go down the periodic table, the size of halogen atom increases. Fluorine atom is smallest and iodine atom is the largest. Consequently, the carbon halogen bond length also increases from carbon fluorine to carbon iodine. Some typical bond length, bond enthalpies and dipole moment are given in table 6.2. Alkyl halide are best prepared from alcohol, which are easily accessible. So carbon halogen bond length, बॉन्ड एंथैल्पी, डाइपोल मोमेंट। सो डाइपोल मोमेंट अगर देखें तो सबसे ज़्यादा किसका है, क्लोरीन का, उसके बाद किसका आ रहा है, फ्लोरीन, मतलब RCl, उसके बाद RF, उसके बाद RI, उसके बाद RBr, मोस्ट इम्पॉर्टेंट ट्रेंड है। और बॉन्ड एंथैल्पी तो इसमें कोई एक्सेप्शन नहीं, सबसे छोटा है, सबसे ज़्यादा इलेक्ट्रोनेगेटिव टच किया है, तो ये इंक्रीज ही हो रहा है और नीचे डिक्रीज हो रहा है। और बॉन्ड लेंथ देखें तो नीचे जैसे बढ़ रहा है बॉन्ड लेंथ इंक्रीज हो रहा है, तो इसमें कोई एक्सेप्शन नहीं है, बट डाइपोल मोमेंट में एक्सेप्शन है, इसको इम्पोर्टेंट करके याद कर लेना। क्लोरीन, उसका फ्लोरीन का अल्किल फ्लोराइड, अल्किल आयोडाइड, उसका अल्किल ब्रोमाइड है। 6.4 मेथड ऑफ प्रिपरेशन ऑफ haloalkanes. 6.4.1 from alcohols. The hydroxyl group of alcohol is replaced by halogen on reaction with concentrated halogen acid, phosphorus halide or thionyl chloride. Thionyl chloride is preferred because in this reaction alkyl halide is formed along with gases SO2 and HCl. The two gases product are escapable. Hence, the reaction given pure alkyl halide. The reaction of primary and secondary alcohol with HCl require the presence of catalyst ZnCl2. With tertiary alcohol, the reaction conducted by simply shaking the alcohol with concentrated HCl at room temperature. Constant boiling with HBr 48%. The used for preparing alkyl bromide. Good yield of Ri may be obtained by heating alcohol with sodium or potassium iodide with 95% orthophosphoric acid. The order of reactivity of alcohol with given haloacid is 3 degree, 2 degree, 1 degree. phosphorus tribromide and triiodide are usually generated in situ, produced in reaction mixture by the reaction of red phosphorus with bromine and iodine respectively. Here alcohol react to HCl in the presence of ZnCl to form RCl and water. Alcohol react with NaBr in presence of sulfuric acid, it form RBr, NaHSO4 and H2O. Alcohol PX3 form alkyl halide and H3PO3. Alcohol in presence of PCl3, RCl plus PSCl3 and HCl. ROH in presence of red phosphorus and X2 form RX. ROH in presence of SOCl2 form RCl and SO2 and HCl. This is most preferred method because SO2 and HCl are escapable and we obtain pure alkyl halide. The preparation of alkyl chloride is carried out either by passing dry halogen chloride gas through solution of alcohol or by heating a mixture of alcohol and concentrated aqueous halogen acid. The above method are not applicable for a preparation of aryl halide because the carbon-oxygen bond in phenol has a partial double bond character and is difficult to break, being strong than a single bond. 6.4.2 from hydrocarbon. First, from alkanes by free radical halogenation. Free radical chlorination or bromination of alkanes give a complex mixture of isomeric mono and haloalkanes, which is difficult to separate as a pure compound. Consequently, the yield of any single compound is low. Here is butane react with chlorine in presence of UV light or heat. It form 1 chlorobutane plus 2 chlorobutane, and it is major product by Markovnikov rule or rule. It follow Markovnikov rule, but it is symmetry. Sorry, इसको मार्कोवनिको रूल फॉलो कर रहे हैं, याद नहीं आ रहा है, रुक जाओ देखने दो. Second, from alkenes. First, addition of hydrogen halides. An alkene is converted to corresponding alkyl halide by reaction with halogen chloride, hydrogen bromide and hydrogen iodide. Alkene react to HX form haloalkane. Propene yield two product. However, only one predominates as per Markovnikov rule. Here propene react to HI form 1 iodopropane plus 2 iodopropane, and this is measured by Markovnikov. यहाँ पे तो Markovnikov फॉलो हो रहा है. देखो Markovnikov अनसिमेट्रिकल यहाँ पे एल्केन में फॉलो होता है, ये सिमेट्रिकल है, इसीलिए मैं सोच रहा था इसमें कौन सा मेजर होगा. Second, addition of halogen. In the laboratory, addition of bromine in carbon tetrachloride to an alkene resulting in discharge of reddish brown color of bromine constitute an important method of detection of double bond in molecule. The addition result in synthesis of cis dibromides which are colorless. तो देखो यहाँ पे ब्रोमीन गैस का रिएक्शन करा है इन प्रेजेंस ऑफ कार्बन टेट्राक्लोराइड, तो विस डाइब्रोमाइड बना रहा है जो कि क्या होता है रेडिश ब्राउन इन कलर. इससे डिटेक्शन कर लेते हैं डबल बॉन्ड का. 6.4.3 halogen exchange. Alkyl iodides are often prepared by reaction of alkyl chloride bromide with sodium iodide and in triacetone. This reaction is known as Finn-Claystone reaction. तो देखो यहाँ पे alkyl halide का रिएक्शन सोडियम आयोडाइड से करा रहा है, तो अल्किल आयोडाइड प्लस NaX बना रहा है. AX यहाँ पे Cl और Br है ओनली. NaCl and NaBr thus form precipitated in triacetone. It facilitates the forward reaction according to Leach-Atelier principle. This synthesis of alkyl fluoride is best accomplished by heating on an alkyl chloride and bromide in presence of metallic fluorides such as AgF, Hg2F2 cobalt difluoride SbF3. द रिएक्शन इज टर्म में स्वार्ट्स रिएक्शन। तो स्वार्ट्स रिएक्शन में क्या बना रहे हैं अपन, CH3Br और HF का रिएक्शन करके एल्किल फ्लोराइड बना रहा है, HBr प्रेसिपिटेट हो जा रहा है। ठीक, तो फिनक्लेस्टीन में क्या रिएक्शन बनाते हैं, फिनक्लेस्टीन में आयोडाइड का एल्किल आयोडाइड बनाएंगे और स्वार्ट्स में क्या बनाएंगे, एल्किल फ्लोराइड स्वार्ट्स में, और फिनक्लेस्टीन में क्या आयोडाइड बना रहा है। 6.5 preparation of haloarenes. First, from hydrocarbon by electrophilic substitution. Aryl chlorides and bromides can be easily prepared by electrophilic substitution of arene with chlorine and bromine respectively in the presence of Lewis acid catalyst like iron or iron third chloride. So this is aryl chlorides react with halogen in iron dark form orthohalotoluene and parahalotoluene. The ortho and para isomers can be easily separated due to large difference in their melting point. Reaction with iodine are reversible in nature and require the presence of oxidizing agent HNO3HiO4 to oxidize the Hi formed during iodination. Fluoro compounds are not prepared by this method due to high electronegativity of fluorine. Second, from amines by Sandmeyer reaction. When primary aromatic amines dissolve in or suspended in cold aqueous mineral acid is treated with sodium nitrite, a diazonium salt is formed. Mixing the solution of freshly prepared diazonium salt with cuprous chloride or cuprous bromide result in the replacement of diazonium group by chloride or bromide. Here aniline react with NaNO2 plus HX at 273 to 278 degree Kelvin. It forms benzene diazonium halide, और benzene diazonium halide react with Cu2X2. this form aryl halide. इसको सैंडमेयर रिएक्शन बोलते हैं ना। Replacement of diazonium group by iodine does not require the presence of cuprous halide and is done by simple shaking diazonium salt with potassium iodide. ठीक, मतलब अगर आयोडाइड फॉर्म करना है तो पोटेशियम आयोडाइड में क्या डाइजोनियम साल्ट को सिर्फ सेक कर देंगे तो ये बन जा रहा है और N2 गैस रिलीज हो जा रहा है। ठीक, 6.6 फिजिकल प्रॉपर्टी. Alkyl halides are colorless when pure. However, bromides and iodides develop color when exposed to light. Many volatile halogen compounds are sweet in smell. So many volatile halogen compounds क्या हैं, sweet हैं smell में. Melting in boiling point. Methyl chloride, methyl bromide, ethyl chloride and some chlorofluoromethanes are gases at room temperature. Higher members are liquid or solid. As we have already learned, molecules of organic halogen compounds are generally polar. Due to greater polarity as well as higher molecular mass as compared to parent hydrocarbon, the intermolecular force of attraction dipole-dipole and van der Waals are strong in halogen derivative. That is why the boiling point of chloride, bromide and iodide are considerably higher than those of hydrocarbon of comparable molecular mass. The attraction gets stronger as the molecules get bigger in size and have more electrons. The pattern of variation of boiling point of different halide is depicted in figure 6.1. For same alkyl group, the boiling point of alkyl halide decreases in order Ri, Rbr and Rcl. This is because with increase in size and mass of halogen atom, the magnitude of van der Waals force increases. So van der Waals force increase हो रहा है तो boiling point increase हो रहा है. तो CH3 methyl ग्रुप के साथ मीथेन, ये हेलोजन ग्रुप इथाइल के साथ कैसे काम कर रहा है और ये प्रोपाइल के साथ कैसे काम कर रहा है. तो क्लोराइड का सबसे कम बॉइलिंग पॉइंट, सबसे ज़्यादा किसका, आयोडाइड को हो रहा है क्योंकि van der Waals फोर्सेस बढ़ रहे हैं. ठीक, द बॉइलिंग पॉइंट ऑफ आइसोमेरिक हेलोएल्केन्स विथ डिक्रीजेज विथ इंक्रीज इन ब्रांचिंग देखो बढ़ रहा है तो क्या बॉइलिंग पॉइंट कम हो रहा है. ठीक, फॉर एग्जाम्पल 2-bromo-2-methyl propane हैज लोवेस्ट बॉइलिंग पॉइंट among 3 isomers. So इसका क्या है, लोवेस्ट बॉइलिंग पॉइंट है क्योंकि ब्रांचिंग, कार्बन तो सेम है, मास सेम है, बट 3 ब्रांच हो गए, यहाँ पे सिंगल ब्रांच, तो सबसे ज़्यादा boiling point of isomeric dihalobenzene are nearly the same. However, para isomers are high melting point as compared to their ortho and meta isomers. It is due to symmetry of para isomer that fits in crystal that is better as compared to ortho and meta isomers. So boiling point यहाँ पे देखो 2 कार्बन ऑर्थो ग्रुप है पैरा पे एंड मेटा पे, तो बॉइलिंग पॉइंट सबसे ज़्यादा किसका है इसमें, ऑर्थो वाले का। और मेल्टिंग पॉइंट सबसे ज़्यादा किसका है, मेल्टिंग पॉइंट भी सबसे ज़्यादा ऑर्थो वाला का है। ऑर्थो वाई रीजन क्या है भाई, पैरा isomers are high melting point is compared to ortho. The boiling point is nearly same. However, para isomers ये para isomers है ना, high melting point is compared to their ortho and meta. इसका high है, it is due to symmetry of para that fits crystal better as compared to meta and, तो भाई यहाँ पे इधर पैरा का ज़्यादा है ना, लेकिन यहाँ पे देखो और हाई मेल्टिंग पॉइंट भाई, ये क्रिस्टल लैटिक्स में अच्छे से फिक्स हो, ये तो समझ में आ रहा है क्योंकि देखो सिमेट्री दिख रहा है। तो बॉइलिंग पॉइंट, हाँ तो देखो मेल्टिंग पॉइंट ज़्यादा है, ठीक, उसके बाद इसका ऑर्थो का, उसका क्लोरो का, ठीक। लेकिन बॉइलिंग पॉइंट का देखो, एक बॉइलिंग पॉइंट ऑर्थो का ज़्यादा है, बॉइलिंग पॉइंट देखो तो ऑर्थो का, उसके बाद पैरा का, उसके बाद मेटा का। बट अगर मेल्टिंग पॉइंट देखेंगे तो सबसे ज़्यादा किसका है, पैरा, उसके बाद ऑर्थो, उसके बाद मेटा। वही मैं बोल रहा हूँ क्या, डेंसिटी, bromoiodine and polychloride derivative of hydrocarbons are heavier than water. The density increases with increased number of carbon atom, halogen atom and atomic mass of halogen group. Table 6.3 density of some haloalkanes compound ये सब हो गया डेंसिटी। तो देखो ये क्या, आयोडीन नीचे आओ तो क्या हो रहा है, सेम कार्बन के लिए डेंसिटी बढ़ता जा रहा है। Solubility, the haloalkanes are very slightly soluble in water. In order to dissolve haloalkanes in water is an energy required to overcome the attraction between haloalkanes molecule and break the hydrogen bond between the water molecules. Less energy is released when new attraction is set up between haloalkanes and the water molecule, as these are not as strong as original hydrogen bond in water. As a result, the solubility of haloalkanes in water is low. However, haloalkanes tends to dissolve organic solvent because new intermolecular attraction between haloalkanes and solvent molecule are much same strong as being broken separated in. तो देखो solubility कम है वाटर में, क्यों, क्योंकि देखो H2O में क्या होता है, H बॉन्डिंग होता है, H बॉन्डिंग, तो H बॉन्ड को तोड़ के इसका हेलोएल्केन के साथ अगर इसका बॉन्ड बनाया तो ये वीक होता है H कंपेयर टू वाटर का हाइड्रोजन बॉन्ड, इसीलिए ये इनसॉल्युबल, स्लाइटली सॉल्युबल और इनसॉल्युबल होता है वाटर में, ठीक। बट ऑर्गेनिक सॉल्वेंट में क्या होता है, सॉल्युबल होगा। अब देखो 6.7 केमिकल रिएक्शन, द रिएक्शन ऑफ हेलोएल्केन्स में बी डिवाइडेड इनटू फॉलोइंग कैटेगरी। फर्स्ट रिएक्शन ऑफ हेलोएल्केन्स देखेंगे तो हेलोएल्केन्स में पहला न्यूक्लियोफिलिक सब्सटीट्यूशन, सेकेंड एलिमिनेशन रिएक्शन, थर्ड रिएक्शन विथ मेटल। तो फर्स्ट पढ़ेंगे न्यूक्लियोफिलिक सब्सटीट्यूशन रिएक्शन। You have learned in class 11 nucleophile are electron rich species, okay, therefore they attack at that part of substrate molecule which is electron deficient, ठीक। The reaction in which nucleophile replaces already existing nucleophile in a molecule called nucleophilic substitution reaction. Haloalkanes are substituted in this reaction. In this reaction, or nucleophile react with haloalkanes, the substrate having a partial positive charge on carbon atom bonded to halogen. A substitution reaction take place and a halogen atom called leaving group departs as halide Since the substitution reaction is initiated by nucleophile, it is called nucleophilic substitution reaction. तो न्यूक्लियोफाइल अटैक कर रहा है यहाँ मिथाइल अल्किल हैलाइड पे, तो क्या बन रहा है, न्यूक्लियोफाइल इससे रिएक्ट कर ले रहा है, तो और ये हेलोजन आयन रिलीज हो रहा है. तो ये पढ़ेंगे न्यूक्लियोफाइलिक सब्सटीट्यूशन रिएक्शन. It is one of the most useful class of organic reaction of alkyl halide in which halogen is bonded to sp3 hybridized carbon. The product formed by the reaction of haloalkanes with some nucleophile are given below. तो देखो यहाँ पे न्यूक्लियोफाइल कैसे रिएक्ट कर रहा है इससे हेलोएल्केन्स से, ये दिखा रहा है. तो देखो न्यूक्लियोफाइल हो गया, रिएजेंट क्या ले रहा है, सब्सटीट्यूशन प्रोडक्ट क्या फॉर्म हो रहा है, क्लास ऑफ मैन प्रोडक्ट. तो देखो NaOH रिएक्ट कर रहा है तो क्या देगा ये, OH न्यूक्लियोफाइल देगा. OH न्यूक्लियोफाइल क्या बना रहा है, ROH. H2O भी H2O न्यूक्लियोफाइल रिएक्ट करके ROH बना रहा है. NOR रिएक्ट कराएंगे तो ROR ईथर बना रहा है. सोडियम आयोडाइड तो अल्किल हैलाइड आयोडाइड बना रहा है. अमोनिया क्या, प्राइमरी अमाइन. अल्किल 1 डिग्री अमोनिया क्या बना रहा है, सेकेंडरी अमाइन बना रहा है. 2 डिग्री अमाइन क्या बना रहा है, ये 1 डिग्री अमाइन हो गया, 2 डिग्री अमाइन टर्सरी अमाइन बना रहा है. KCN RCN नाइट्राइल बना रहा है. AgCN क्या बना रहा है, RNC बना रहा है. ये देखो आइसोसाइनाइड फॉर्म कर रहा है AgCN, और KCN क्या फॉर्म कर रहा है, साइनाइड. ये मोस्ट इम्पॉर्टेंट है, इसको रिएक्शन आ सकता है. KNO2 क्या फॉर्म कर रहा है, एल्किल नाइट्राइड. AgNO2 क्या फॉर्म कर रहा है, नाइट्रो एल्केन. दिस रिएक्शन इज आल्सो मोस्ट इम्पॉर्टेंट. RC11O ये क्या बना रहा है, एस्टर बना रहा है. लिथियम एल्यूमिनियम हाइड्राइड R देखे हाइड्रोकार्बन फॉर्म कर रहा है. Rm प्लस रिएक्ट करके मेटल के साथ तो एल्केन फॉर्म हो रहा है. ग्रुप ऑफ साइनाइड एंड नाइट्राइड्स पोसेस 2 न्यूक्लियोफिलिक सेंटर कॉल्ड ambident nucleophile. Actually, cyanide group is a hybrid of 2 contributing structure and therefore can act as nucleophile in 2 different ways. तो ये साइनाइड कार्बन से डायरेक्ट जुड़ सकता है या नाइट्रोजन से जुड़ सकता है. लिंकिंग थ्रू हेल थ्रू कार्बन रिजल्टिंग इन अल्किल साइनाइड. अगर मान लो कार्बन से यहाँ पे ऐड हो रहा है तो अल्किल साइनाइड फॉर्म करेगा, और नाइट्रोजन से कर रहा है तो क्या फॉर्म करेगा, इससे आइसोसाइनाइड बना लेगा. Similarly, nitrite ion also represent an ambident nucleophile with 2 different point linkage. The linkage through oxygen resulting in alkyl nitrite. अगर ऑक्सीजन से लिंक बना रहा है तो अल्किल नाइट्राइट, और नाइट्रोजन से रिएक्ट बना रहा है तो नाइट्रोएल्केन्स. मैकेनिज्म क्या है, द रिएक्शन हैज बीन फाउंड टू प्रोसीड इन 2 different mechanism which is described as below. A. Substitution nucleophilic bimolecular SN2 reaction. The reaction between alkyl chloride, a methyl chloride, and hydroxide ion to yield methanol and chloride ion follows a second order of kinetics. SN2 क्या second order of kinetics follow कर रहा है. The rate depends upon concentration of both reactants. So here is hydroxide ion and here is methyl chloride react to form. देखो यहाँ पे, देखो यहाँ क्लोरीन यहाँ पे था, ऑक्सीजन इसके यहाँ का अपोजिट जुड़ रहा है, तो यहाँ पे क्या हो रहा है, इन्वर्जन भी हो रहा है. दिस सॉलिड वेज रिप्रेजेंट बॉन्ड कमिंग आउट द पेपर. तो ये जो सॉलिड वेज है दिखा रहा है पेपर के बाहर आ रहा है इलेक्ट्रॉन, एंड गोइंग डाउन एंड डैश एज डैश जो है ये दिखा रहा है पेपर के अंदर ये वो बॉन्ड फॉर्मेशन हुआ. द रेड बाल रिप्रेजेंट द इनकमिंग हाइड्रोक्साइड आयन एंड ग्रीन बाल रिप्रेजेंट द आउटगोइंग हैलाइड. सो ये रेड बॉल क्या कर रहा है, हाइड्रोक्साइड कैसे आ रहा है, जुड़ रहा है इससे, और ये हैलाइड आयन कैसे बाहर जा रहा है, तो इन्वर्जन हो रहा है ना. In the year 1937, Edward Davis Hughes, Sir Christopher Ingold proposed the SN2 reaction. किसने दिया, Edward Davis Hughes and Christopher Ingold. It depicts the bimolecular nucleophilic substitution SN2 reaction. The incoming nucleophile will interact with alkyl halide, causing the carbon halide bond to break, and new bond is formed between carbon and attacking nucleophile. Here it is carbon oxygen bond formed between carbon and hydroxide ion. These two processes take place simultaneously in single step and no intermediate is formed. This is single step and no intermediate form. As the reaction progresses, and the bond between the incoming nucleophile and carbon atom start forming. The bond between carbon atom and leaving group weakens. As this happens, the 3 carbon hydrogen bond of substrate start moving away from the attacking group of nucleophile. In transition state, all the 3 carbon hydrogen bond are in the same plane, and the attacking and leaving group nucleophile are partially attached to the carbon. If the attacking nucleophile approaches closer to the carbon hydrogen bond still keep on moving in the same direction till the attacking nucleophile attached to carbon and leaving group leaves the carbon. As the result, configuration is inverted. The configuration C box of carbon atom under attack inverts in such a way as an umbrella is turned inside out when caught in a strong wind. This process is called inversion in configuration. In the transition state, the carbon atom is simultaneously bonded incoming nucleophile and outgoing leaving group. Such structures are unstable and cannot be isolated. Thus, in transition state, the carbon is simultaneously bonded to 5 atoms. Configuration, spatial arrangement of functional group around carbon is called configuration. See the structure A and B below carefully. This is mirror image. These are two structures of same compound. They differ in spatial arrangement. Functional groups attached to carbon. Structure A is mirror image of B. We say configuration of in structure A is mirror image of configuration of carbon structure B. Hughes worked under in gold and earned the DSc degree under University of London. Since this reaction required the approach of nucleophile to the carbon bearing leaving group, the presence of bulky substituents on the near of the carbon atom have dramatically inhibiting effect of the simple alkyl halide. Methyl halide react most rapidly in SN2 reaction because there are only 3 small hydrogen atoms. Tertiary halide are least reactive because bulky group hinder the approaching nucleophile. Thus, reactivity 1 degree, 2 degree and then 3 degree. Reactive of SN2. Steric effect in SN2 reaction. The relative rate of SN2. So here is methyl. How methyl से react कैसे कर रहा है, ethyls कैसे react किया, how it is reacting to isopropyl and how it is reacting to tertiary butyl. B substitution nucleophilic unimolecular. SN1 reaction. SN1 reaction is generally carried out in polar protic solvent like water, alcohol, acetic acid, etc. The reaction between tertiary butyl bromide and hydroxide ion yields tertiary butyl alcohol and follow the first order of kinetics. The rate of reaction depends upon concentration of only one reactant, which is tertiary butyl bromide. 2 bromo 2 methyl propane react कर रहा है हाइड्रोक्साइड से to form 2 methyl propane to all. It occurs in 2 steps. First step is polarized carbon bromide bond undergoes slow cleavage to produce carbocation and a bromide ion. The carbocation thus formed is then attacked by nucleophile in step 2 to complete the substitution reaction. So here is how step first form carbocation and then hydroxide react to form CS3 1 2 2 methyl 1 compound dimethyl butanol. Step 1 is solvent and reversible. It involves carbon bromide bond breaking, for which energy is obtained through solvation of halide ions with proton of protic solvent. Since the rate of reaction depends upon solvation step, the rate reaction depends only on the concentration of alkyl halide and not on the concentration of hydroxide. Further, the greater the stability of carbocation, greater will be ease of formation of alkyl halide and faster will be the rate of reaction. In case of alkyl halide, 3 degree alkyl halide undergoes SN1 reaction very fast because high stability of 3 degree carbocation. We can sum up the order of reactivity of SN1 and SN2 as follows. तो SN2 का reactivity क्या है 1 degree, then 2 degree, then 3 degree, and SN1 का क्या है 3 degree का सबसे ज़्यादा उसका 2 degree, उसके बाद 1 degree SN1, this is SN2. For the same reason, alkyl and benzylic halides show high reactivity to SN1, SN2. The carbocation form get stabilized through resonance, as shown in figure. तो ये कार्बोकेटाइन फॉर्म हुआ रेजोनेंस से स्टेबलाइज हो गया. फॉर अल्किल ग्रुप द रिएक्टिविटी ऑफ अल्किल हैलाइड फॉलो सेम ऑर्डर फॉर बोथ मैकेनिज्म. अल्किल हैलाइड के लिए RI, RBr, RCl and RF. These are order of alkyl halide, how these reacts. C. Stereochemical aspects of nucleophilic substitution reaction. In order to understand the stereochemical aspect of substitution reaction, we need to learn some basic stereochemical principle and notation: optical activity, chirality, retention, inversion, and racemization, etc. First, optical activity. Plane polarized light produced by passing ordinary light through nickel prism is rotated when it is passed through the solution of certain compound. Such compounds are called optically active compounds. The angle by which the plane polarized light is rotated is measured by an instrument called polarimeter. If the compound is rotated by the plane of polarized light in right direction or clockwise direction, it is called dextrorotatory, Greek for right rotation, or deform, and is indicated by placing positive sign before the degree of rotation. If the right is rotated to a left anti-clockwise direction, the compound is said to be lever rotatory, or the L form, and a negative sign is replaced before the degree of rotation. Such as positive and negative isomers are compound optical isomers, and the phenomena is termed optical isomerism. Second, molecular symmetry, chirality and enantiomers. ये करने से पहले यहाँ देख लेते हैं. William Nicol 1768 to 1851 developed the first prism that produced plane polarized light. तो निकोल प्रिज्म इसीलिए बोला जाता है. ओके. Molecular asymmetry, chirality and enantiomers. The observation of Louis Pasteur in 1848 that crystal of certain compounds exist in the form of mirror image laid the foundation of modern stereochemistry. He demonstrated that the aqueous solution of both type of crystals showed optical rotation equal in magnitude for solution of equal concentration but opposite in direction. He believed that this difference in optical activity was associated with three-dimensional arrangement of atom in molecule configuration of two type of crystal. Dutch scientist J. van 't Hoff and French scientist C. L. in same year 1874 independently argued that spatial arrangement of four groups valency around a central carbon is tetrahedral. If all the substituents attached to that carbon are different, the mirror image of the molecule is not superimposed overlapped on molecule. Such a carbon is called asymmetrical carbon or stereocenter. The resulting molecule would lack symmetry and is referred to asymmetrical molecule. The asymmetry of molecule along with non-superimposability of mirror image is responsible for optical activity of such organic compound. The symmetry and asymmetry is also observed in many day-to-day objects. A sphere, a cube, a cone are all identical to their mirror image and are superimposed. However, many objects are non-superimposable on their mirror image. For example, your left and right hand look similar, but if you put your left hand on right hand by moving them to same plane, they do not coincide. The objects which are non-superimposable on their mirror image, like a pair of hands, are said to be chiral, and this property is known as chirality. Chiral molecules are optically active, while objects which are superimposable on mirror image are achiral. These molecules are optically inactive. The above test of molecular chirality can be applied to organic molecules by constructing model and its mirror image by drawing three-dimensional structure and attempting to superimpose them in our mind. Therefore, are other aids, however, that can assist us in recognizing chiral molecules. One such aid represents a single asymmetric carbon atom. Let us consider two simple molecules, propane 2-ol and butane 2-ol, and their mirror image. B is mirror image of A, B is rotated to 180 degree, and C is obtained. C is superimposable to A. Some common example of chiral: achiral. These are chiral object, non-superimposable mirror image, and these are non-chiral image, superimposable image. The object that cannot superimpose on mirror image is called chiral. As you can see clearly, propane 2-ol does not contain any asymmetric carbon, as all the 4 carbon attached to tetrahedral carbon are not different. We rotate the mirror image B molecule of 8 by 180 degree and try to overlap the structure C with structure A. These structure completely overlap. Thus, propane 2-ol is an achiral molecule. E is a mirror image of D. E is rotated by 180 degree to get F, and F is non-superimposable mirror image of D. A chiral molecule and the mirror image. Butane 2-ol has 4 different groups attached to the tetrahedral carbon and expected is chiral. Some common example of chiral molecules such as 2-chlorobutane, 2,3 dihydroxypropanol, bromochloroiodomethane, 2-bromopropanoic acid, etc. The stereoisomerism related to each other as non-superimposable mirror image are called NCERT. A and B in figure 6.5 and D and E are in figure 6.7. NCERT possess identical physical property, namely melting point, boiling point, refractive index, etc. They only differ with respect to rotation of plane polarized light. If one of the NCERT is dextrorotatory, the other will levorotatory. However, the sign of optical rotation not necessarily related to absolute actual configuration of a molecule. A mixture containing 2 NCERTs is equal proportion will have 0 optical rotation, as the rotation due to one isomer will be cancelled by rotation due to other isomer. Such a mixture is known as racemic mixture or racemic modification. A racemic mixture is represented by prefix DL or plus minus before the name. For example, plus minus butane 2-ol. The process conversion of NCERT into racemic mixture is known as racemization. Retention. Retention of configuration is the preservation of spatial arrangement of bond to an asymmetric center during the chemical reaction or transformation. In general, if during a reaction no bond or stereo center is broken, the product will have same general configuration of groups around the stereo center as that of reactant. Such a reaction is said to proceed in retention of configuration. Consider as an example the reaction that takes place when 2-methyl 1-ol is heated with concentrated hydrochloric acid. So यहाँ से देखो ऑक्सीजन निकला और यहीं पे आ गया क्लोराइड जुड़ गया, तो इसको क्या बोलेंगे? रिटेंशन. It is most to note that configuration at symmetric center in the reactant and product is same, but the sign optical rotation has changed in product. This is so because two different compounds with same configuration at asymmetrical center may have different optical rotation. One may be dextrorotatory plus sign optical, while other may be levorotatory negative. So this is levorotatory and this is dextrorotatory. Inversion, retraction and racemization. There are three outcomes for reaction of asymmetrical carbon atom. When a bond directly linked with asymmetric carbon atom is broken, consider the replacement of X and Y in the following reaction. Here, यहाँ से देखो, यहाँ से X निकला, Y यहीं पे जुड़ा, तो इसको क्या बोलेंगे? रिटेंशन. यहाँ से X निकला, Y इसके अपोजिट आके जोड़ रहा है, इसको क्या बोलेंगे? दिस इज इन्वर्जन. सो A हो गया रिटेंशन एंड B व्हाट इन्वर्टेड B, उसका अपोजिट आगे जोड़ रहा है. In 50-50 mixture of A and B obtained, then a process is called racemization and product optically inactive. As one isomer will be rotated, the plane polarized light in direction opposite to the another. Now let us have fresh look at SN1 and SN2 mechanism by taking example of optically active alkyl halide. In case of optically active alkyl halide, the product formed as a result of SN2 mechanism has the inverted configuration as compared to the reactant. This is because nucleophile attached to itself on the side opposite to one where the halogen atom is present. When 2-bromooctane is allowed to react with sodium hydroxide, dextrorotatory octane to wall, the formed element hydroxide group occupying the same position toward bromide had occupied. तो देखो इसका अपोजिट आ गया तो इन्वर्जन हो गया. SN2 रिएक्शन ऑप्टिकली एक्टिव हैलाइड accompanied inversion, तो SN2 में क्या हो रहा है, इन्वर्जन हो रहा है. In case of optically active alkyl halide, SN1 reaction are accompanied by racemization. SN1 में क्या हो रहा है, racemization हो रहा है, 50-50% बन रहा है. Can you think the reason why it happened? Actually the carbocation formed by slow step being sp2 hybridization planar achiral. The attack of nucleophile may be accomplished from either side of plain carbocation, resulting in mixture of products, one having the same configuration, the OH attaching to the same carbon halide, and the other having opposite configuration, the OH attaching on side opposite to halide ion. This may be illustrated from hydrolysis of optically active 2-bromobutane, which result in formation of plus minus butane 2-ol. So यहाँ देख कैसे रिएक्शन कर रहा है, OH आके जुड़ा ब्यूटेन 2-ol और ये दोनों फॉर्म कर रहा है. तो ये क्या है, SN1 में रेसमाइजेशन हो रहा है ना, क्योंकि L और D दोनों फॉर्म हो रहा है. Location of alpha and beta carbon in a molecule. Carbon on which halogen atom is directly attached is called alpha carbon, and the carbon atom adjacent to carbon is called beta. तो ये अल्फा कार्बन डायरेक्टली हेलोजन जुड़ा है, तो और बीटा जो सेकंड पे अल्फा और गामा क्या उससे तो थर्ड वाले पे जो जुड़ा है. सेकंड एलिमिनेशन रिएक्शन. When haloalkane with beta hydrogen atom is heated with alcoholic solution of potassium hydroxide, there is elimination of hydrogen atom from beta carbon and halogen atom from alpha carbon atom. तो देखो ये अल्फा, यहाँ पे बीटा हाइड्रोजन है और ये रिएक्ट कर रहा है कौन सा, पोटेशियम हाइड्रोक्साइड रिएक्ट किया तो डबल बॉन्ड फॉर्म हो गया, एल्किन बन गया एल्किल हैलाइड से. X is लिविंग ग्रुप, B क्या है, बेस है. As a result, an alkene is formed as product. Since beta hydrogen atom is involved in elimination, it is called beta elimination. देखो बीटा हाइड्रोजन क्या एलिमिनेट हो में इन्वॉल्व है, इसलिए बीटा एलिमिनेशन बोल रहे हैं. If there is possibility of formation more than one alkene due to availability of more than one beta hydrogen atom, usually one alkene is formed as major product. These form part of a pattern first observed by Russian chemist Alexander Zaitsev, also pronounced as Zaitsev, who in 1875 formulated a rule which can be summarized as: in dehydrohalogenation reaction, the preferred product is that alkene which has greater number of alkyl group attached to the doubly bonded carbon atom. Thus 2-bromopentane gives 2-pentuene as major product. तो देखो 1 2 3 4 5 2-ब्रोमोपेंटेन एल्कोहल को प्रेजेंट किया, पेंटुइन और पेंटुइन बना रहा है. तो एक किसके रूल है, जेटसेव रूल क्या होगा, पेंटुइन क्या हो रहा है, मैक्सिमम यील्ड कर रहा है, मैक्सिमम फॉर्म हो रहा है. और एलिमिनेशन वर्सेस सब्स्टिट्यूशन रिएक्शन में क्या डिफरेंस आ रहा है. A chemical reaction resulting in competition, it is the race of who win fastest runner. A collection of molecules tend to do by and large what is easiest of them. An alkyl halide with beta hydrogen atom when reacted with base of nucleophile has two competing routes: substitution SN1 and SN2, elimination. Which route will be taken up depends upon nature of alkyl halide, strength and size of base nucleophile and reaction condition. Thus a bulky nucleophile will prefer to act as base and abstract a proton rather than approach a tetravalent carbon atom steric region, and vice versa. Similarly, a primary alkyl halide will prefer as SN2 reaction. A secondary halide SN2 or elimination depending upon strength of base nucleophile, and tertiary SN1 or elimination depending upon stability of carbocation और मोर सब्सटीट्यूट एल्किन. सो हियर इज एलिमिनेशन एंड यहाँ पे क्या हो रहा है, सब्सटीट्यूशन हो रहा है. 3 reaction with metal. Most organic chloride, bromide and iodide react with certain metal to give compound containing carbon metal bond. Such compound is known as organometallic compound. An important class of organometallic compound discovered by Victor Grignard in 1900 is alkyl magnesium halide, RMGX, referred to as Grignard reagent. These reagents are obtained by reaction of haloalkanes with magnesium metal in dry ether. So here is alkyl ethyl bromide react with magnesium to form in presence of dry ether form Grignard reagent. Victor Grignard had a strange start in academic life of chemist. He took math degree. When he eventually switched chemistry, it was not the mathematical province of physical chemistry but to organic chemistry. While attempting to find efficient catalyst for process of methylation, he noted the zinc in diethyl ether had been used for the purpose and wondered whether magnesium ether combination might be successful. Grignard reagents were first reported in 1900 and Grignard used his work for his doctorate thesis in 1901. In 1910, Grignard obtained a professorship at University of Nancy. In 1912, he was awarded with Nobel Prize for Chemistry, which he shared with Paul Sabatier, who had made advances in nickel catalyst hydrogenation. In Grignard reagent, the carbon-magnesium bond is covalent but highly polar. With carbon pulling electron from electropositive magnesium, the magnesium halogen bond is essential ionic. So this is ionic form, ionic bond. Grignard reagents are highly reactive and react with any source of proton to give hydrocarbon. Even water alcohol amine are sufficient acidic to convert them to corresponding hydrocarbon. So RMGX water से react करके क्या बना, हाइड्रोकार्बन बना रहा है plus MgOH. It is therefore necessary to avoid the trace moisture of Grignard reagent. तो Grignard में moisture नहीं होना चाहिए, नहीं तो क्या बना ले रहा है, हाइड्रोकार्बन. That why reaction with carried in dry acetone. On the other hand, this could be considered one of the method for converting halides to hydrocarbon. ये भी मेथड है हाइड्रोकार्बन बनाने का. देखो डायरेक्ट RMGX से भी बनाया जा सकता है. जैसा वुड्स रिएक्शन, alkyl halide react with sodium in dry ether to give hydrocarbon containing double the number of carbon atom present in halide. This is reaction known as Woods reaction. वुड रिएक्शन क्या हो रहा है, alkyl halide रिएक्ट कर रहा है सोडियम ड्राई ईथर के प्रेजेंस में, फॉर्म कर रहा है क्या, डाई अल्काइल. 6.7.2 reaction with haloarenes. First, nucleophilic substitution. The aryl halides are extremely less reactive toward nucleophilic substitution reaction due to following reason. First, resonance effect. In haloarenes, the electron pair of halogen atom are in conjugation with pi electron of ring and the following resonating structure are possible. So यहाँ पर रेजोनेंस हो रहा है, देख लो भाई, इसलिए कम लेस रिएक्टिव होता है. Carbon chloride bond require a partial double bond character due to resonance. As a result, the bond cleavage haloarenes are difficult and haloalkanes, and therefore they are very less reactive toward nucleophilic substitution reaction. तो nucleophilic reaction के क्या है, बहुत कम कर रहा है वो. Second, difference in hybridization of carbon atom to CX bond. In haloalkane, the carbon atom attached to halogen in sp3 hybridized, while in case of haloarenes, the carbon atom attached to halogen is sp2 hybridized. So ये है sp2 hybridized carbon है, यहाँ पे sp3 hybridized carbon. The sp2 hybridized carbon with greater s character is more electronegative and can hold electron pair CX bond more tightly than sp3 hybridized carbon in haloalkanes with less s character. Thus, carbon chloride